People work from different places, and behind all that, network has to keep up without getting in the way. This is where Cisco Nexus dashboard comes in. Instead of managing the network through many different tools, Nexus dashboards bring everything together in one place. It helps teams run a network more smoothly and with far less manual effort. A lot of network work used to be repetitive, setting things up again and again, checking configurations, making sure changes were about done the same way everywhere. And Nexus dashboards automates much of that work. It reduces the human error and keeps the network consistent as it grows. Another big advantage is the visibility. We can clearly see what is happening across the network. You can quickly understand the health of your systems, and you can see which devices are running well and where attention may be needed. Instead of reacting after problem happens, teams can spot issues earlier and respond faster. So this also changes how engineers will spend their time. They're no longer tied up with routine configuration tasks. They spend less time fixing small issues. They spend more time improving the network and supporting new business goals. The network becomes something that supports the growth instead of slowing it down. As environments expand, managing multiple locations becomes more complex. The Nexus dashboard simplifies this by allowing teams to manage data centers, campuses, and cloud environments in a consistent way. New devices can be brought online faster. This is my lab. Changes can roll out across multiple sites with confidence, like managing of this VPN, EVPN, VXLAN data center, east and west. All right, everything is controlled from a single central view. The platform also provides insights over time. It helps teams understand patterns in new behavior. It highlights unusual activity. It supports better planning and smarter decisions based on real data. Next dashboard replaces old and disconnected tools with one intelligent platform. It makes daily operations easier, improves reliability, and it allows network to grow alongside business without adding unnecessary complexity. This is my lab, simulates a multi-site, data centers enterprise network with two data center east and west, providing hands-on experience with VXLAN, Nexus dashboard, and advanced fabric concepts. The East Data Center represents a full-scale environment, including Nexus switches, one the core switch, one border gateway, two spine switches, two leaf switches, and a border leaf switch, and an external switch to simulate the connectivity to outside networks. It also hosts some Ubuntu servers which are used to validate connectivity, test segmentation, and verify routing and policy configurations across the lab. The West data center is a smaller, scaled down site that complements the East environment. It includes a core router, a border gateway spine switch, and a leaf switch, and two servers providing additional endpoints for testing and validation. Together, these two sites create a realistic framework for learning enterprise-grade network operations, showcasing how Cisco Nexus dashboard simplifies multi-site management, automation, and orchestration. Start by creating a new fabric in a greenfield environment using Nexus dashboard. A greenfield environment means starting with a clean development, free of existing configurations or legacy constraints, making it ideal for building a data center fabric from the ground up. The goal of this lab is to guide you through the initial setups of creating a VXLAN EVPN based LAN fabric, which serves as groundwork for automated and scalable data center operations. You will start by defining the fabric parameter, then onboarding and assigning roles to the switches. Finally, we will confirm the underlay setup and learn about the required configurations and a process that Nexus dashboard simplifies significantly. All right, we'll build a East fabric, a VXLAN EVPN based network fabric that provides a scalable layer 2 and layer 3 connectivity across the data center. This fabric will form the foundation for virtualized network services and seamless integration with other sites in the overall architecture. Let's create a fabric. In the fabric wizard, we're going to give a name, East, and we'll pick a data center VXLAN EVPN. This lab we're working with virtual Nexus 9000 series switches, which are ideal for data center development. However, it is worth noting that a data center Nexus dashboard also supports campus fabric deployment, which allow us to onboard and manage Catalyst 9000 series switches alongside Nexus devices. This flexibility enables a unified fabric management approach across both data center and enterprise campus environment. In Nexus dashboards, when creating a new LAN fabric tailored to specific use cases and network architectures, the classic you will find is classical LAN option is intended for traditional layer 2 and layer 3 campus style development without VXLAN overlays. The we in later version the Nexus dashboard fabric controller is an AI fabric type is designed for AI ML workloads, offering optimized configuration for high throughput, low latency environment, typically using RDMA over converged Ethernet ROCE. And external and inter-fabric connectivity is used to create a fabric dedicated to managing external connectivity between multi-data center fabrics or with external network. And you will find the routers option supporting simple layer 3 routed technologies without overlay, ideal just for smaller or more straightforward environment. Then in later version, you will have IP fabric for media. I have a video about that. Check it out. Is a fabric type purpose built for media and broadcast networks, providing the deterministic multicast and low latency streaming capabilities. So each of these options allow Nexus dashboard to tailor the provisioning and policy model to match the specific operational needs of a chosen fabric type. Okay, get our topic. It will pick data center VXLAN EVPN. On this screen, you will be presented with two configuration modes, like you have a default or advanced in that version. Here, we will provide a simplified setup. This we're needing only a few key inputs such as a fabric name, BGPS number. So in that case, we're putting out 65010. I encourage you to explore all of these options your own to become more familiar with the platform's full capabilities. For now, we'll highlight just a few most significant sections that are commonly used in the data center environment. I'll leave all the default values as provided. Okay. In general parameters, fabric interface numbering typically set to P2P determines how interfaces are addressed. The underlying subnet IP mask is /30 sets the IP range for spine leaf links. The underlay routing protocol SPF is selected, enabling dynamic routing in the underlay. The route refactor usually set to specify how many spine nodes will reflect the BGP routes across the fabric, and any cast MAC address ensures the consistent gateway addressing for host mobility. These settings are essential for underlaying connectivity and a stable fabric operation. And we could go to replication. Here we configure how bomb traffic broadcasts on known unicast and multicast, called bomb trap BUM, is handled in the fabric, setting the replication mode to multicast. All right, allows efficient traffic distribution using the underlay. And the multicast group subnet is 239.1.1.0/25, provides IPs for each overlay network. The underlay multicast group address limit typically was set to 128, being typical for older NXOS versions. All right, let's jump to VPC. Sets key parameters for virtual port channels. So the VLAN range defines here VLAN for the peer link with an option to make it native, right? Auto recovery and delay restore times control failover and recovery behavior. The port channel ID here identifies the peer link port channel. These settings support VPC stability and high availability. Let's jump to protocol. Defines the here key underlying protocol settings for VXLAN EVPN fabric. Loopback 0 is used for routing, OSPF or BGP, and Loopback 1 serves as a VTAP IP, and Anycast Loopback may be configured to provide a consistent gateway, commonly used when VPC is deployed, but also applicable in all other redundancy or load balancing scenarios. The routing protocol tag identifies the underlay OSPF process. The OSPF area ID typically is 0.0.0, sets the backbone area, and optional OSPF authentication secures the neighbor adjacencies. Next, let's review advanced section. So this section defines the overlay setting for VXLAN EVPN fabric. The VIF and the network templates set how VIF and VNIs are created to on-leaf switches, where extension templates apply them to border nodes for external connectivity. Overlay modes controls whether configuration is pushed via profiles or CLI. Options like enable L3 VNI without VLAN simplify just VRF to VNI mapping, and enable PVLAN allows more granular segmentation with an option like a PVLAN secondary network template to define the secondary PVLANs. Together, these settings determine how overlay VRFs and networks are defined and extended across the fabric. Finally, let's look at resources. Here, we can define and relay on default values for key underlay resources, including like routing, loopback IP range, VTAP loopback range, multicast RP range, and the underlay subnet range used for numbers interface and the peer link SVI IPs. So feel free to explore on your own the other tabs that I did not cover in this lab right now. Once ready to continue, and let's click save. Now, when I create a fabric in Nexus dashboards and save it, the system builds a new fabric object in its database using my inputs, AS number, factory names, etc. It automatically generates the global policies and underlay templates like loopbacks, BGP settings, telemetry options, but does not yet push anything to devices. So at this stage, Fabric exists logically in the data Nexus dashboards and is ready for device discovery and onboarding, where the actual underlay configuration will be deployed. All right. You can double click here to check um, the fabric details. The dashboards here, right here, detailed information about your fabric, including health, inventory, and the configuration status. Since no switches have been onboarded yet, most of the sections will be empty. However, you can modify the initial configuration if you need it, as we will in this lab. So to do this, I can go action and edit fabric. In next few steps, I will make a few small modification just to see how it works. Under fabric management, right? We'll go to replication. We'll select the checkbox for auto-generate the new multicast group address. Here you go. And it will allow Nexus dashboard automatically assign unique multicast addresses for VXLAN bomb traffic replication, helping segment bomb traffic efficiently and simply for the setup. And we'll see more about this later on. Next, let's go to advanced. In here, it's recommended to allow switches to reload and boot up normally to ensure a clean and stable deployment. However, to speed up the lab exercise, we'll use here reload. We'll use disable when this greenfield cleanup option is enable clean switches configuration without reload. Okay. Let's go to resources. Let's scroll down to VF Lite development section. And select back-to-back to external from the drop-down menu. And we want to check box for auto deploy for peer below. Once done, let's click save. The back-to-back to external, let me go over this again. This is what we set it up. Back-to-back to external. Option in the Nexus dashboard automates the creation of VF Lite interfabric connections, IFC. So between the border devices of different fabrics and between border devices and external edge routers like the manual mode, where each connection must be manually configured, including interface selection, IP addressing, and VF mapping. This option streamlines the process by automatically provisioning the links and assigning IP addresses from a predefined VF Lite subnet IP range, and the auto deployment for peer option ensures that both sides of the interfabric connections are automatically configured. The Nexus dashboard pushes the VF Lite settings not just to local border devices, but also to peer fabrics and devices as long as they are NXOS or ASR9K devices, eliminating the needs for manual setup on the remote site. This simplifies deployment and ensures the consistency and reduces configuration errors. All right.
Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below. Hey everyone, NetMaven here. Don't forget to hit that subscribe button to dive into the world of amazing network technologies with me, and please feel free to leave your comments below.